You're listening to the Bare Metal Cyber Prepcast, created to help you succeed in your educational journey. Learn more at baremetalcyber.com, where additional prepcasts, books, and training materials await. Let's get started. Human-AI interaction is the field that studies how people use, understand, and collaborate with artificial intelligence systems. It goes beyond technical performance and into the lived experience of users who must interpret AI outputs, provide feedback, and decide whether or not to trust the system's recommendations. This interaction is not one-sided. Just as humans learn to use AI tools, the tools themselves often adapt to human preferences and behaviors. The study of this relationship is critical because the most advanced algorithm is of little value if people cannot understand or use it effectively. Think of a car with a powerful engine but a confusing dashboard. It may have potential but fails to deliver. For learners, human-AI interaction emphasizes that intelligence must be paired with usability. Success lies not only in building models that work mathematically, but in designing systems that communicate clearly and integrate smoothly into human contexts. Usability is one of the most decisive factors in determining whether AI systems are adopted and trusted. A model might achieve impressive accuracy in predicting outcomes, but if the interface is confusing, users may avoid it or misinterpret its recommendations. Intuitive design ensures that people can quickly grasp what the system is doing and how to interact with it. For example, an AI-powered medical tool must present its insights in a way that doctors can understand immediately, often under time pressure. Poor usability can lead to frustration, errors, and rejection of the technology altogether. Conversely, clear, user-friendly interfaces can encourage trust and confidence, helping users feel supported rather than overwhelmed. For learners, usability highlights that AI is never just about performance behind the scenes. It is about how effectively those results are conveyed and applied in the hands of real people making real decisions. User interfaces serve as the bridge between AI outputs and human interpretation. Dashboards display metrics and predictions in structured, often visual, formats that allow users to track trends and make decisions. Apps bring AI to everyday contexts, embedding recommendations into navigation, shopping, or health monitoring. Voice assistants create conversational channels, enabling users to interact with AI systems in natural spoken language. Each interface type has strengths and weaknesses. Dashboards provide detail but may overwhelm. Apps simplify interactions but may limit transparency, and voice assistants offer convenience but struggle with nuance. For learners, the key point is that the user interface is not a cosmetic feature, but a central element of AI usability. A well-designed interface determines whether insights remain trapped within the system or are successfully translated into meaningful human action. Visualization of AI outputs plays a crucial role in making complex models comprehensible. Predictions are often probabilistic, and simply outputting a label like approve loan or deny loan obscures the uncertainty behind the decision. Visualization tools such as probability bars, risk scores, or ranked recommendations provide richer information that helps users understand not just what the model predicts, but how confident it is. Explanatory graphics may highlight which features influenced the decision most, such as income level or repayment history in credit scoring. These visualizations empower users to question, validate, or contextualize AI results, fostering informed decision-making. For learners, visualization highlights that numbers alone are not enough. Clear visual communication is necessary to bridge the gap between technical complexity and human understanding, turning opaque predictions into transparent insights that users can trust and act upon. Conversational interfaces represent one of the most direct forms of human-AI interaction, as chatbots and virtual assistants engage in dialogue with users. These systems interpret natural language input, provide responses, and often complete tasks such as booking appointments or answering queries. The strength of conversational interfaces lies in their accessibility. Users do not need training to type a question or speak a request. However, the challenge is ensuring that the system handles ambiguity, context, and user expectations effectively. A frustrating or unhelpful chatbot can erode trust quickly, while a well-designed assistant can feel almost seamless. For learners, conversational interfaces illustrate the promise of natural interaction, where AI becomes less of a tool and more of a partner, but also the difficulty of aligning machine responses with human communication norms. Natural language interfaces expand this idea, allowing humans to interact with AI through text or speech rather than technical commands. These interfaces reduce barriers to use, enabling people to express themselves in everyday language. For example, a user might ask, "What's my spending trend over the last 3 months?" instead of navigating complex spreadsheets. Behind the scenes, the system parses the request, translates it into structured queries, and delivers a meaningful answer. Natural language interfaces are especially powerful in domains like customer service or education, where users expect responsive and adaptive dialogue. However, they must contend with ambiguity, slang, and cultural variation. For learners, natural language interaction underscores both the accessibility and complexity of AI. Making systems more natural for users requires solving some of the most challenging problems in language understanding. Adaptive interfaces personalize interactions by adjusting to user behavior over time. An AI-driven news app, for instance, may notice which topics a reader engages with most and adjust the feed accordingly. Similarly, a fitness tracker might adapt its feedback based on progress, offering encouragement or challenge depending on performance trends. Adaptive interfaces enhance usability by reducing cognitive load, surfacing the most relevant information, and making systems feel responsive to individual needs. Yet they also raise concerns about over-personalization, where users are trapped in narrow filter bubbles. For learners, adaptive interfaces highlight the dual role of personalization. It can improve user experience but must be carefully managed to avoid limiting exposure to diverse perspectives or overwhelming users with excessive tailoring. Human factors shape every aspect of interaction with AI systems. Concepts like cognitive load, trust, and user expectations directly affect whether systems are embraced or resisted. If an interface demands too much effort to interpret, users may abandon it. If AI results appear inconsistent or inexplicable, trust erodes. Conversely, when systems align with natural human expectations, they feel intuitive and empowering. For example, an AI navigation app that provides step-by-step instructions matches how people already think about directions, reducing cognitive load. Human factors remind us that users are not passive recipients of AI but active participants, bringing their own perspectives, biases, and limitations. For learners, this shows that human-centered design is not optional, but essential. Understanding people is as critical as understanding algorithms when building successful AI systems. Transparency in interfaces enhances trust by making AI decisions more interpretable. Explanations of why a recommendation was made, disclosures about model limitations, and clear communication of confidence levels all contribute to user confidence. For instance, a loan approval system that says, "This decision was influenced by your credit history and income-to-debt ratio," provides more reassurance than a simple yes or no. Transparency also encourages accountability, enabling users to question and challenge results when necessary. Without transparency, AI systems risk being perceived as arbitrary or opaque, which undermines adoption. For learners, transparency illustrates how interface design is intertwined with ethics. The way results are presented can determine whether users trust, contest, or reject AI outputs, making openness a vital feature of responsible design. Feedback loops with users are critical in improving AI systems. Interfaces that allow users to confirm, reject, or correct outputs create opportunities for continuous refinement. For example, a recommendation engine may adjust its suggestions based on whether users click, ignore, or downvote certain items. Similarly, translation systems improve when users edit results. Feedback transforms interaction into collaboration, with users helping to fine-tune models in real time. However, feedback must be designed carefully to avoid reinforcing bias or overfitting to vocal subgroups. For learners, feedback loops demonstrate the dynamic nature of human-AI interaction. Systems are not static. They evolve in partnership with their users, improving only when designed to listen and adapt to human input responsibly. Error handling in AI interfaces is an often overlooked but crucial aspect of usability. Mistakes are inevitable, whether due to imperfect models, ambiguous input, or unexpected scenarios. The key is how the system responds. A poorly designed AI might give nonsensical answers without acknowledging the error, leaving users confused or frustrated. Effective error handling involves gracefully admitting limitations, offering alternatives, or guiding users toward corrections. For example, a chatbot might respond, "I didn't understand that. Did you mean X or Y?" Such responses preserve trust and maintain engagement even when systems falter. For learners, error handling highlights that perfection is not the goal in AI. Reliability comes from resilient systems that recover from errors transparently and helpfully are often more trusted than those that pretend to be flawless. Personalization in human-AI interaction involves tailoring outputs, recommendations, and interfaces to individual users. Streaming platforms customize movie suggestions, e-commerce sites personalize product recommendations, and educational systems adapt lessons to student progress. Personalization increases relevance and user satisfaction, making AI systems feel attentive to individual needs. However, it also raises concerns about privacy and autonomy, as extensive personalization requires collecting and analyzing sensitive user data. Over-personalization may reduce exposure to diverse perspectives or create echo chambers. For learners, personalization demonstrates both the benefits and risks of tailoring AI to individuals. Done responsibly, it enhances usability and engagement. Done carelessly, it undermines privacy and broadens ethical challenges. Balancing these outcomes is central to designing systems that respect individuals while enhancing their experiences. Accessibility in AI interfaces ensures that systems are inclusive of users with disabilities. This involves designing features like screen readers, voice commands, and adaptive input methods that make AI tools usable by people with visual, auditory, or motor impairments. For example, text-to-speech and speech-to-text technologies enable communication for those with hearing or vision challenges. Accessibility is not only a legal or ethical requirement, but also a way to broaden adoption and impact. Inclusive design benefits everyone. Captions aid not only the hearing impaired but also users in noisy environments. For learners, accessibility underscores that usability must extend across the full range of human diversity. AI systems succeed when they empower all users, not just the average or able-bodied. Designing for inclusivity makes technology more robust, equitable, and widely beneficial. Trust calibration refers to balancing how much users rely on AI with how critically they engage with its outputs. If trust is too low, users may ignore valuable recommendations, wasting the system's potential. If trust is too high, users may over-rely, accepting flawed advice without scrutiny. Calibration ensures that users apply AI as a tool rather than a crutch, maintaining oversight while benefiting from automation. For example, in aviation, pilots must understand when to trust autopilot systems and when to intervene. Interfaces that communicate uncertainty and limitations help users calibrate trust appropriately. For learners, trust calibration shows that usability is not about blind faith, but informed partnership. AI should support human judgment, not replace it, making balanced reliance a central principle of safe and effective human-AI collaboration. Collaboration between humans and AI systems represents the ultimate goal of interaction: joint decision-making, where each party contributes strengths. AI brings speed, scale, and pattern recognition, while humans bring context, ethics, and creativity. In healthcare, a diagnostic AI may flag potential concerns, but doctors interpret them within the broader clinical picture. In business, recommendation engines suggest opportunities, but managers weigh them against strategy and values. Collaboration requires interfaces that support partnership, presenting AI outputs as aids rather than directives. For learners, collaboration highlights the future of human-AI interaction. Systems designed not to replace but to augment human capability, creating teams of people and machines working together to achieve goals more effectively than either could alone. For more cyber-related content and books, please check out cyberauthor.me. Also, there are other prepcasts on cybersecurity and more at baremetalcyber.com. Human-centered design principles form the backbone of effective AI interfaces. This approach prioritizes user needs and experiences rather than focusing solely on technical achievement. Designers begin by asking what problems users are trying to solve and how AI can assist, rather than forcing people to adapt to machine logic. Prototyping, testing, and iteration ensure that systems evolve with feedback from real users, not just developer assumptions. For example, in designing a medical AI dashboard, developers consult clinicians to ensure information is presented in ways that support decision-making under pressure. Human-centered design also emphasizes simplicity, clarity, and accessibility, ensuring that systems reduce rather than increase cognitive load. For learners, these principles remind us that the success of AI is measured not only in accuracy or efficiency, but also in how seamlessly it integrates into human workflows. Systems that align with human strengths and needs foster adoption, trust, and meaningful impact. Explainable AI interfaces take transparency a step further by embedding explanations into user interactions. Rather than delivering results as opaque outputs, these systems provide reasons for predictions, highlighting the features or patterns that influence the decision. For instance, a financial risk model might indicate, quote, "This loan was denied primarily due to debt-to-income ratio and inconsistent repayment history." Such explanations empower users to understand, contest, or correct results, building trust and accountability. They also help users calibrate reliance on the system, distinguishing between high confidence and more uncertain predictions. Explainability does not require overwhelming users with technical detail, but providing enough clarity to make outputs interpretable and actionable. For learners, explainable interfaces illustrate that AI is not only about producing answers but also about communicating reasoning. This ensures that human partners remain engaged, informed, and in control of decisions influenced by AI. Visual explanations of AI outputs enhance comprehension by using intuitive graphics and simplified models. Instead of raw numbers or abstract probabilities, interfaces may use bar charts, color highlights, or heat maps to indicate which inputs mattered most. In medical imaging, saliency maps can highlight regions of a scan that influenced a diagnosis, directing attention to areas of concern. In text analysis, important phrases can be underlined or color-coded to show their weight in classification. Visual explanations reduce the cognitive effort needed to interpret complex models, making insights more accessible to non-technical users. However, they must balance simplicity with accuracy, avoiding oversimplifications that mislead. For learners, visual explanations demonstrate how design choices transform technical outputs into human-readable forms. They reveal that successful AI interaction is as much about presentation as it is about computation, ensuring that the bridge between models and users is strong, clear, and trustworthy. Confidence indicators are another essential feature of AI interfaces, helping users understand uncertainty. Rather than presenting predictions as absolute, systems can show probability scores or confidence ranges. For example, a medical diagnostic tool might state that it is 90% confident in one diagnosis but only 55% confident in another. This information allows doctors to weigh recommendations appropriately, considering AI input alongside other clinical evidence. Similarly, in weather forecasting, confidence bands around temperature predictions inform how much weight people should place on the forecast. Confidence indicators calibrate trust, preventing over-reliance on uncertain outputs while ensuring that high-confidence predictions are recognized. For learners, these indicators highlight that AI systems are not infallible oracles, but tools that operate with degrees of certainty. Communicating that uncertainty clearly is vital for safe, effective, and ethical use in human-AI collaboration. Multimodal interfaces combine multiple channels: text, speech, visuals, and sometimes even haptics to enrich human-AI interaction. These systems allow users to engage with AI in the way that feels most natural or convenient for the context. For example, a driver may issue voice commands to a navigation system while also viewing highlighted routes on a dashboard screen. In healthcare, a patient monitoring system may provide visual charts, verbal alerts, and tactile notifications to ensure important information is communicated effectively. Multimodal interfaces reduce dependency on a single mode of interaction, increasing accessibility and flexibility. They also mirror how humans naturally process information through multiple senses simultaneously. For learners, multimodal design emphasizes that AI is most effective when it adapts to human communication styles, offering redundancy and richness in interaction that accommodates diverse needs and scenarios. Emotional intelligence in AI interfaces reflects the growing recognition that communication is not only about content, but also about tone, empathy, and responsiveness. Systems that detect user emotions through voice inflection, facial expressions, or text sentiment can adjust their responses accordingly. For instance, a customer support chatbot might recognize frustration in a user's message and escalate to a human agent or adopt a more empathetic tone. Emotional intelligence can make interactions feel more natural, supportive, and effective, especially in domains like education, healthcare, or customer service. However, it also raises ethical concerns about manipulation and privacy, as emotion detection involves sensitive personal cues. For learners, emotional intelligence highlights both opportunity and responsibility. AI that responds to emotion can enhance usability and trust, but it must do so transparently and respectfully, safeguarding human dignity and autonomy in the process. Ethical challenges in interaction go beyond technical concerns to include manipulation, over-reliance, and autonomy. Interfaces can subtly influence decisions through design choices, such as emphasizing certain recommendations over others. This can become manipulative if users are steered toward outcomes that serve organizational goals rather than their own interests. Over-reliance occurs when users trust AI outputs uncritically, surrendering decision-making to machines. At the same time, interfaces that obscure uncertainty or hide limitations erode autonomy, leaving people unable to exercise informed judgment. Ethical interaction design requires careful attention to these risks, ensuring that systems support rather than undermine human agency. For learners, ethical challenges demonstrate that usability is not value-neutral. Every design choice carries ethical weight, shaping whether AI empowers or exploits the humans who depend on it. Responsible interaction design requires vigilance, humility, and a commitment to fairness. Cross-cultural considerations remind us that interaction styles are not universal. The way people expect to communicate with systems varies across societies, shaped by cultural norms, language, and values. For instance, directness in instructions may be expected in some cultures but perceived as rude in others. Colors, symbols, and gestures can carry very different meanings across regions. An AI tutor designed for American classrooms may need significant adjustments to be effective in Japan or Brazil. Failing to account for these differences risks alienating users or reinforcing stereotypes. Cross-cultural design requires engagement with diverse communities, testing systems in varied contexts, and remaining sensitive to local customs. For learners, this highlights that global AI deployment demands more than technical translation. It requires cultural humility and adaptability. Interfaces must respect and reflect the diversity of human expression if they are to foster trust and usability across the world. Human-in-the-loop systems emphasize shared control between AI and humans, ensuring that critical decisions are not left entirely to machines. These systems present AI outputs as recommendations rather than directives, allowing humans to confirm, modify, or override results. For example, in medical imaging, AI may highlight suspicious regions in a scan, but radiologists make the final diagnosis. In aviation, autopilot systems handle routine navigation, but pilots retain ultimate authority. This shared control prevents over-reliance while leveraging AI's strength in speed and pattern recognition. For learners, human-in-the-loop systems demonstrate the principle of augmentation. AI is most effective when it complements rather than replaces human judgment. Collaboration between humans and machines ensures that decisions reflect both computational power and human context, creativity, and responsibility. Training users to work effectively with AI is an often overlooked but critical element of usability. Even the best-designed system can falter if users do not understand its capabilities, limitations, or appropriate use cases. Training can take the form of onboarding tutorials, guided demonstrations, or ongoing education. For example, a hospital introducing AI diagnostic tools must train doctors not only in the mechanics of use, but also in interpreting confidence scores, recognizing potential errors, and integrating results with clinical judgment. Without this training, risks of misuse or over-reliance increase. For learners, user education highlights that interaction is not solely about machine design. It is also about human preparation. Empowering users with knowledge ensures that collaboration is safe, effective, and aligned with intended outcomes. AI usability depends as much on informed users as on transparent systems. Workflows enhanced by AI illustrate how human-AI interaction integrates into practical tasks. In business, AI dashboards analyze sales data, helping managers identify trends and make informed decisions. In logistics, AI interfaces optimize routing and scheduling, saving time and reducing costs. In creative industries, AI tools assist with design, music composition, or video editing, providing suggestions while leaving control with human creators. These enhanced workflows demonstrate that AI does not exist in isolation, but as part of broader systems of work. Interfaces must integrate smoothly with existing tools, supporting productivity without disruption. For learners, workflows emphasize that usability is judged by outcomes. Does AI save time, reduce effort, or expand capability? Effective interaction design ensures that the answer is yes, making AI a natural and valuable extension of human work. Healthcare applications of human-AI interaction demonstrate both promise and responsibility. Clinical decision support systems assist doctors by analyzing patient data and suggesting diagnoses or treatment options. Patient-facing tools, such as chatbots, engage individuals with symptom checkers, medication reminders, or personalized health advice. These systems must balance usability with transparency, ensuring that users understand recommendations while protecting privacy. A doctor who trusts AI assistants must also be able to explain decisions to patients, maintaining accountability. For learners, healthcare interaction illustrates the stakes of usability. Effective design can improve outcomes, save lives, and build trust, while poor design risks confusion or harm. It shows how human-AI collaboration in medicine depends on careful integration of usability, ethics, and responsibility. Educational applications of human-AI interaction highlight the transformative potential of personalized learning. AI tutors adapt lessons to individual progress, offering additional practice when students struggle and advancing when they succeed. Interfaces may present interactive exercises, explanations, or encouragement tailored to each learner's needs. For teachers, AI dashboards provide insights into class performance, helping identify areas where intervention is needed. Usability in this context requires balancing personalization with transparency, ensuring students and educators understand how recommendations are made. For learners, education demonstrates how interaction design can empower growth, providing individualized support that scales beyond what human teachers can offer alone. It also underscores that effective interaction requires clarity, fairness, and inclusivity, ensuring all students benefit equitably from AI-driven learning tools. Business applications of human-AI interaction show how usability drives organizational adoption. Decision dashboards summarize complex analytics into actionable insights for managers. Customer service platforms use AI chatbots to handle routine inquiries, while escalating complex cases to human agents. Automation oversight systems allow employees to monitor, guide, and adjust AI-driven processes, ensuring accountability. These applications illustrate how AI interfaces enhance productivity while maintaining human control. For learners, business contexts highlight that usability is not abstract. It affects profitability, customer satisfaction, and competitiveness. Companies adopt AI not just for technical performance but for how well it integrates into workflows, supports employees, and improves outcomes. Human-AI interaction in business underscores that trust and usability are inseparable from value creation. The future of human-AI interaction points towards systems that are more natural, transparent, and collaborative. Advances in natural language processing, multimodal design, and explainability promise interfaces that feel more conversational, intuitive, and trustworthy. Emotional intelligence may allow systems to detect and respond to human states more effectively, while adaptive design will tailor interactions to individual contexts seamlessly. At the same time, ethical and cultural challenges will remain, requiring careful stewardship to ensure that systems empower rather than manipulate. For learners, the future of interaction is a call to broaden perspective. The goal is not simply to make AI smarter, but to make it a better partner for humans. The trajectory is towards systems that enhance human capability, respect autonomy, and foster collaboration, shaping how people integrate AI into daily life, work, and society at large. Thanks for tuning in to the Bare Metal Cyber Prepcast, your trusted source for cybersecurity news and insights. Remember to subscribe at baremetalcyber.com so you never miss an update. And visit cyberauthor.me for best-selling cybersecurity books that equip you with expert knowledge. Until next time, stay secure and stay vigilant.